In this video, we will discuss exponential expressions, equations, and formulas. Many scientific, technical, and business phenomena have the property of exponential growth. The growth rate does not remain constant, but increases exponentially. We can see the difference by looking at the graphs of the functions f of x equals 2x in red and g of x equals 2 to the x in blue. 2 to the x is said to increase exponentially. G of x equals 2 to the x is an exponential function. On the other hand, 2x increases at a constant rate, and f of x equals 2x is a linear function, since 2x is a linear polynomial. Many formulas have terms that contain exponents. An exponential expression is an expression that contains at least one term that has a variable exponent. A variable exponent is an exponent that has at least one variable factor. Exponential expressions can be evaluated on a calculator by using the general power key, which is just supposed to be that little caret there, not the parentheses before it, or other power keys as appropriate. An exponential equation or formula contains at least one term that has a variable expression. Evaluate the exponentials. 5 to the 6th power equals 5 times 5 times 5 times 5 times 5 times 5, which is 15,625. 4 to the negative 3rd power is 4 to the 3rd to the negative 1st power, which is 4 times 4 times 4, all to the negative 1st power, which is 64 to the negative 1st power, which is 1 over 64, or 0.015625. That's 15,625 hundred-thousandths. 8 to the 2.5 cannot be evaluated by hand the same way that we evaluate the other two examples, but we can recall that this is 8 to the 5/2, which is 8 to the 5th to the 1/2, which is the square root of 8 to the 5th, or the square root of 32,768, which when plugged into a calculator gives us 181.019336. A commonly used formula that contains a variable exponent is the formula for calculating the compound amount of for compound interest. Compound interest for an investment or loan is the interest calculated at the end of each period and then added to the principal for the next period. The compound amount, sometimes called the accumulated amount, future value, or maturity value, is the combined principal and interest accumulated over a period of time. To find the compound amount, or accumulated amount, A equals P times 1 plus R over N all to the nt power, where A is the accumulated amount, P is the original principal, T is the time in years, R is the rate per year expressed as a decimal equivalent, and N is the compounding periods per year. Using the formula A equals P times 1 plus R over N to the NT, find the accumulated amount on an investment of $1,500 invested at an interest rate of 9% for 3 years. The interest is compounded quarterly. For this problem, P equals 1,500, T is 9%, N equals 4, since quarterly means 4 times per year, and T is 3 years. We plug this into a calculator to find A equals 1,500 times 1 plus 0.09 over 4, all to the 4 times 3 power, which is approximately $1,959.07. The accumulated amount of the $1,500 investment after 3 years is $1,959.07 to the nearest cent. To find the compound interest, find the compound amount as previously shown, and then subtract the original principal from the accumulated amount, I equals A minus P. Find the compound interest on an investment of $10,000 at 2% annual interest compounded semi-annually for 3 years. Here, P equals 10,000, R equals 2%, which is 0.02, N equals 2, since semi-annually means twice a year, and T equals 3. I equals A minus P equals 10,000 times 1 minus 0.02 over 2, all raised to the 2 times 3 power, minus 10,000, which is $615.20 to the nearest cent. The present value of an investment is the lump sum amount that should be invested now at a given interest rate for a specific period of time to give a specific compound amount in the future. To find the present value, P equals A over 1 plus R over N raised to the NT power. The seventh inning sports shop needs $20,000 in 10 years to replace engraving equipment. Find the amount the firm must invest at the present if it receives 5% interest compounded annually. Here, A equals 20,000, R equals 5%, which is 0.05, N equals 1, and T equals 10. So P equals 20,000 over 1 minus 0.05 over 1 raised to the 1 times T, which is about $12,278.27. To have 20,000 in 10 years, the shop must invest $12,278.27 now. In advertising or in stating the terms of an investment or loan, it is common to equate the compound interest rate to a comparable simple interest rate. This rate is referred to as the effective rate, annual percentage rate, APR, or annual effective yield. To find the effective rate, E equals 1 plus R over N raised to the N power minus 1. Find the effective interest rate for a loan at 10% compounded semi-annually. Here, R equals 10% or 0.10 and N equals 2. So E equals 1 plus 0.10 divided by 2 all squared, which is 0.1025. The effective interest rate is 10.25%. An annuity is a fund that accumulates compound interest as periodic payments that are added to the principal. An ordinary annuity has periodic payments that are made at the end of each payment period. To find the future value of an ordinary annuity, apply the formula FV equals PN over R times 1 plus R over N raised to the NT power minus 1. Find the future value of an ordinary annuity of $6,000 payment made semi-annually for 5 years at 6% annual interest compounded semi-annually. Here, P equals 6,000, R equals 6%, which is 0.06, N equals 2, and T equals 5. So FV, the future value, is 6,000 times 2 over 0.06 times 1 plus 0.06 over 2 raised to the 2.5%, 2 times 5% minus 1, which is $68,783.28. Sinking fund payments. When you have a specific future goal or target amount that you want to accumulate, a sinking fund payment is the amount you would invest in periodic payments to reach this goal. To determine a sinking fund payment, the known values are the future goal or amount and the expected or guaranteed interest rate. To find the sinking fund payment to produce a specified future value, apply the formula P equals FV times R over N times 1 plus R over N to the NT minus 1. A municipality has established a sinking fund to retire a bond issue of $500,000, which is due in 10 years. The account pays 8% quarterly interest. Find the amount of the quarterly sinking fund payment. Here, FV equals 500,000, R equals 8%, equals 0.08, N equals 4, and T equals 10. So P equals 500,000 times 0.08 over 4 times 1 plus 0.08 over 4 to the 4 times 10 power minus 1, which is $8,277.87. Find the monthly payment to repay a loan. Finding the monthly payment to repay a loan is similar to the process for finding the sinking fund payment. The repayment of the loan in equal installments that are applied to the principal and interest over a specific amount of time is called the amortization of the loan. To find the monthly payment for an amortized loan, apply the formula M equals P times R over N times 1 minus 1 plus R over N to the negative NT, where M is the monthly payment. Find the monthly payment on a 25-year home mortgage of $135,900 at 4%. Here, P equals $135,900, R is 4%, or 0.04, n equals 12, and t equals 25. So m equals 135,900 times 0.04 over 12 times 1 minus 1 plus 0.04 over 12 to the negative 12 times 25, and that's $717.33. In these slides, I chose to minimize the number of variables you would need to remember, which meant taking some of the formulas a little more complicated than they appear in the book. The book uses a couple of different variables, r and n, to represent combinations of other variables that appear in most of these formulas. In particular, r equals r over n, the quotient of the interest rate and number of annual compounding payments, and n equals nt, the product of the number of annual compounding periods and time in years, often referred to as the total number of compounding periods. The simplified formulas are in the book if you wish to use them, but you must remember that capital R does not equal lowercase r, and capital N does not equal lowercase n. The natural exponential, E, is an irrational number that appears in the discussion of many physical events. It is equal to the value of 1 plus 1 over n raised to the n power as n gets very, very large. The value of E to 9 decimal places is 2.718281828. To evaluate formulas containing E, we must use a calculator or computer. We really don't want to multiply these things out by hand. Evaluate E to the 2.7th power using a calculator. That should be raised to the 2.7. I made a mistake there. I used the scientific calculator at www.desmos.com. You can just type E caret 2.7 and you'll get the number below, 14.879737172, which you can probably round to 1 or 2 decimal places without any problem. I am going to pause here and continue this in the next video.